All right, guys, here we go. Chapter 9, Section 4. Here's an example, another example of math induction. So, using math induction, this is the more advanced problem that you might see. Okay? Using math induction, prove that 9 to the n minus 3 to the n will always be divisible by 6. It's a really strong, powerful statement if you think about it. Okay, so what this says is that no matter what you plug in for n, when you subtract 9n minus 3n, the answer you get will always be divided by 6. Okay, no matter what you use for n. So for example, let's say I want to do n equals 2, right? So that means 9 squared minus 3 squared is equal to, right, 72. And we know that 72 is divisible. In other words, you can divide by 6 perfectly. That's what it means to be divisible. So that means 72 divided by 6, I can divide that perfectly. And yes, I can. I get 12. That's what this statement is saying. Now, this is very powerful because it says no matter what you pick for n, for the power, this will always be able to be divided perfectly. So in other words, if n equals 3, 9 to the third minus 3 to the third, okay, this is 729, okay, minus 27, 702. Now, is 702 divisible by 6? Okay, so that's the question they're saying. 702, can we divide it by 6 perfectly? And it comes out, yeah, we can. So 117. So that's what this statement is saying. So no matter what we pick for the power, the result will always be divisible by 6. Even if I pick a random power, like something kind of high up there, like 6. Okay. 9 to the 6th power minus 3 to the 6th power. Okay. So 9 to the 6th power is going to be a really big number, 531,441 minus, okay, let's see, 3 to the 6. Okay, so that's 729. Okay. And that's going to give you 530,712. And the question is, hey, can we divide this by 6? Is it possible? And if you tried it, it would divide perfectly and you get 88,452. See, so doesn't matter what you pick for the power. That's what this statement says, right? It will always be divisible. That's a really powerful statement. Okay, so last example. Okay, so let's say n equals 8. 9 to the 8th minus 3 to the 8th. Okay, so 9 to the 8th. Okay, so let's see. 9 to the 8th power is going to be a really big number. Okay, it looks like 43,046,721 minus 3 to the 8th, 6,561. Okay, so we're looking at we're looking at 43,040,160. And so the question is, hey, can we divide this by 6? And when we do, we get a beautiful number right here, 7,173,360. See, it comes out perfect again. So this statement works when it's n equals 2, 3, 6, 8, right? But what we want to try to do is use math induction and show that it's going to work no matter what we plug in. Okay, so here we go. We're going to do the math induction proof. Okay, so again, step 1, show true for n equals 1. You know, just this is a simple trivial case. You know, we want to plug in n equals 1. So 9 to the 1 minus 3 to the 1 equals 6, and that's divisible by 6. Okay, so that's a check. All right, so now we show that it works for 1. And, you know, I've shown you a couple cases. And so by now you're starting to believe, hopefully. Okay, so because I've shown you a couple cases, you're like, okay, well, let's just assume that it does work. So that's what step 2 is. Step 2, you have to write assume true for some random number down the road, n equals k. All right, since it works for, you know, 2, 3, 6, 8, we're going to assume that's going to be true for some random number k. All right, so in other words, we're going to assume that 9 to the k minus 3 to the k is divisible by 6. Now, what does it mean to be divisible by 6? Divisible by 6 means it's going to be 6 times some number. All right, divisible by 6 means I can break that answer down to be like 6w, right? That's how I know when something is divisible by 6. I can rewrite it as 6 times something else, right? So for example, you know, 12 is divisible by 6 because it's 6 times 2. 30 is divisible by 6 because it's 6 times 5, all right? 72 is divisible by 6 because 6 times 12, right? So any number that's divisible by 6 can be written as 6 times that. So 102 is divisible by 6 because it's 6 times 17, right? So see, this last number is arbitrary. It doesn't matter. It's divisible because I can rewrite that number as a 6 times something else. So in other words, when it's divisible by 6, it can be written as 6 times w, okay? Now, this w is gonna be confusing to some, but it's just arbitrary, just a dummy variable, okay? You can call it anything you want. You can call it t or z or a, doesn't matter, okay? Now, step 3, we're gonna prove true for n equals k plus 1. Okay? Okay, so what we're trying to prove, we're trying to get to this statement here. We're trying to prove that 9 to the k plus 1 minus 3 to the k plus 1, right? We're plugging in k plus 1 into here, equals, right? 9 to the, we're trying to prove that 9 to the k plus 1 minus 3 to the k plus 1 is going to be divisible by 6. In other words, it's going to be written as 6 times t, right? We're trying to prove this right here. Now, this has to equal 6t at the end. Again, t is just an arbitrary number. It kind of arbitrary letter, kind of like w. I couldn't use w again because w was for this power. So being it's going to be a new power, I'm going to have a new number. Therefore, it's going to be 6 times something else, not w. It's going to be t. And so I'm going to try to prove this, okay? All right, so again, we always use our assumption to get to this statement, okay? We're trying to get to this statement right here, okay? So we always use the assumption. All right, let's work with the assumption here. The assumption is that it's true. This is a true statement. And we want to use this to get to where we're trying to go to, 6w, okay? We're trying to get to here, all right, mathematically. So how do we do that? All right, so what we're going to do, all right, what we notice is that this is 9 to the k plus 1, and what I currently have is 9 to the k. So how do I increase this power by 1, okay? Well, if you remember your algebra, if I multiply 9, okay, on both sides, then it's going to be 9 times 9k, 9 to the k, minus 9 times 3 to the k equals 9 times 6 times w, okay? Now, what's 9 times 9 to the k? If you remember your power rules, this is 9 to the k plus 1, okay? Now, there's a little trick here. What I'm trying to do is make this guy become 3k plus 1. But this is a 9, and so it can't immediately become 3 to the k plus 1. What I gotta try to do is try to break this down. Okay, so minus, okay, I can make this a k plus 1 if I break down the 9 as 6 plus 3, like that. 9 is 6 plus 3, right? We all know that. And then I still have my 3k there. And then this is 6 times 9w. So again, I'm just going to I'm going to switch these out. I'm going to put 6 in front. Okay, so now let's distribute this and you'll see something happening. 9 to the k plus 1 minus, now when we distribute, we distribute in here, we get 3 to the k times 3. That's minus 3 times 3 to the k minus 6 times 3 to the k equals 6 times 9w. Okay, now remember your power rules. 9 to the k plus 1 minus this becomes 3 to the k plus 1, right? Now, what we're going to do next is move this guy over here, okay? Because look, we got our proof part right here already. So this box is nice and neat. That's what we're trying to get. And so when we move this over, we get equals 6 times 9w plus 6 times 3 to the k power, okay? So 9 to the k plus 1 minus 3 to the k plus 1 equals, now see how they have a 6 in common? Factor that out, 6, okay? 9w plus 3 to the power k. Now, what we have is the left-hand side of our proof. 9 to the k plus 1 minus 3 to the k plus 1 equals 6 times something else, right? Now, what is this guy? Well, if you think about it, it's going to be some random number, right? So if you think about it, this is going to be 9 to the k plus 1 minus 3 to the k plus 1 equals 6. Now, what is 9w plus 3k? It's just a number, right? A random number. So let's call this random number something else. It can easily be t. There it is. Okay? So that's what we're trying to prove. We don't know what w is, and so we don't know what 9 times w is, and we add 3 to the k, we don't know what the result is, but we're going to name this thing a variable, okay? And we can simply name it t. It's just an arbitrary number, a letter, okay? So we are done with our proof. We did proof there, okay? So hopefully you understood that. And this part is kind of tricky for a lot of people. They always have trouble with this being all of a sudden a t, all right? But if you understand this, the key is that the 6 makes this thing divisible, not the 9w or the 3k. It's 6 times something, which makes the entire right-hand side divisible by 6. Okay, so 6t, that's the finishing product of our proof. All right, hopefully you understood that.